Alright guys, today I'm going to go do, this is Firestarter 12. I'm going to give you most of the 1.5 notes, probably half to 2/3 of it, and I'm going to go over Firestarter 11. Shouldn't be that long. I'm going to go a little bit quick, so remember you can always pause this if needed. The first of this started off with definitions, so you could have looked them up online, you could have looked them in the book, the back of the book, in the section, a bunch of ways to find it. I'm going to kind of give you what I think is the easiest way to think of it, maybe not necessarily 100% mathematically. So a square root is the number being multiplied by itself. So for example, if I said, what is the square root of 9? The square root of 9 is equal to 3, because 3 times 3 is 9. So a square root is basically trying to figure out what number can be multiplied by itself to give you whatever answer you're looking for. The radical is the symbol, or sometimes it's the whole expression. The radicand is the number or just the stuff, because it doesn't have to be a number, it could be variables. So it's the stuff inside the radical. Alright. Rationalizing the denominator. Rationalizing the denominator means that there cannot be a radical in the bottom of a fraction. Now we're going to use the word is called conjugates. Alright, now conjugates are pairs of expressions usually, or I can't think of a case, but they are radical expressions, so they have square roots involved some way or another. They're pairs of expressions that multiply together. This is important. To make the radical go away. That's why they're very huge, because radicals sometimes get complicated, and there's like this like magic special pair that makes the radical disappear from one spot. It won't disappear from the expression, but it disappears from a spot. Now if you didn't realize it, the stuff we just written down was kind of explained right here. So a number r is a square root of a number s if r squared is equal to s. That's basically saying what we talked about with square roots, that r multiplied by itself is s. So if that's true, then we get to say it's a square root. Alright. A positive number s has two square roots denoted by radical s and negative radical s. This is where things get kind of messy. So if I take the square root of 4, right, square root of 4 could actually be 2, or it could be negative 2, because 2 squared equals 4, or, so that means because, or negative 2 squared equals 4. So a lot of times when you're evaluating square roots, it's going to give you two choices, and that's going to be important, because remember, sometimes when we solved last section, we had two answers. We had x equals this or x equals this. So this would be a way to continue that. Oh, there's an example right here. Boom. And that kind of is just another example of what I explained. Right? Since 4 squared is 16 and negative 4 squared is 16, the two square roots of 16 are 4 and negative 4. We'll use this symbol all the time. It's called plus or minus because math guys are lazy. So this means plus or minus. So if you see that, it means plus or minus. The symbol itself is called the radical sign. The number beneath the radical sign is called the radicand. So the stuff inside is called the radicand. It doesn't have to necessarily be number. It could be anything. Number, expression, variables. And the entire thing together, they'll sometimes call the radical too. I usually will just say the radical is a radical. But if they want to be picky, you'll say a radical sign is just the symbol. And then the whole thing together is radical. All right. Product property. So this is going to be two things we use all the time. So if I have the square root of a times the square root of b, then I can put them together. And it works both ways. So remember, this also works both directions, where I could say I have a times b and I split it up only with multiplication. This does not work with addition. So somebody's going to do this. Never, right? Never this. Never. Square root of a plus square root of b equals square root of a plus b. Never do that. That's never allowed to happen. All right, and a lot of people make that mistake all the time. This is specific for multiplication. That's why it's a product property. The quotient property. It's very similar. It just kind of looks like this. It says the square root of a over the square root of b can be split together. A over b, or like I said, you can always split things up. So it can, and the equal sign, like mathematically, you don't have to write it. Like mathematically, I did not have to write it this way, from left to right, and then right to left. The equal sign means both directions. I'm just writing it both for you guys so you can see it a little bit better. So most math guys will never write it both directions, but I'm just going to write it just in case you're struggling with that. So you could have a fraction inside the radical, and you could split it up. Take the radical at the top and radical at the bottom. And you'll use either way. Sometimes you'll use what's easier, whatever's easier for you. All right? Now the next thing that's really important is you have to remember a square root expression must be simplified. And we're going to spend basically, before we do any algebra like solving equations and stuff like that, we have to learn how to use radicals. Basically because here's the idea. When we did our problems with factoring, we got nice answers. Even if fractions showed up, they were nice answers. I don't know if you guys remember, but one of the ways I knew you guys were cheating and using photo math was because you had radical answers on stuff that I made it not possible to solve. A lot of things have possibilities to solve, but you can't use factoring. This is one of the ways we can solve stuff that cannot be factored. And radicals will show up in your answer. But if you don't know how to use a radical, then, or simplify a radical, it gets really messy. So no radicand, so a radical, so inside this radical, you're going to have some sort of number or expression, something, right? You're going to have x's, variables, whatever. It cannot have a perfect square factor other than 1. There is no radical in the bottom. Those are the rules that you need to follow. That's it. Right? I'm going to go a lot more detail about that, so don't stress out. And I'm going to kind of explain how I explain it. I think it works out pretty well. The keyword is perfect. The keyword is perfect. All right, so guys, before we go any further, we have to know about perfect squares, because them radicals and perfect squares work together. I think of the radical as a jail, right? So this radical to me is a jail. So he's a jail. If you go to jail, the only way you can get out of jail is if you're perfect. If you have perfect behavior, you get to leave jail. So you can only leave if perfect. The other thing you have to do is you have to change. Because if you were in jail for whatever you did, and you left and you didn't change, you're probably going to go right back to jail. Now here's how I explain that mathematically. So let's say we had the square root of 9. 9 is perfect. And what I mean by perfect is he can be rewritten as 3 squared. So he changed. So the little 2 and the radical cancel out. So the square root of 9 is just plus or minus 3, because remember, you could have a positive 3 times 3 to give you 9, or negative 3 times negative 3 is also 9. But so 9 had to change to get out of jail. He left jail. All right, we're going to talk about that a lot. So here's how we start off. The first thing you have to know whenever you do this is you have to know perfect squares. So you need to know 1 squared is 1. You need to know 2 squared is 4. I'll make that better. You need to know that 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. 15 squared is 225. That's probably good, but I'll keep on going. 16 squared is 256. I have to check that in a second. That's early. 17 squared is 289. Put a little star by that to make sure I got to check that one. 18 squared is 324. Oh, I almost wrote down the wrong thing. 19 squared is 361. I think that's right. I got to double check that one too. And then 20 squared is 400. I just double checked. Those are both good. So our goal is going to find a factor. Right? We want a factor that is a perfect square. So I'm going to look. So guys, we did factors when we were doing factoring. I'm not going to use any number. I only want to have perfect square factors. Alright, that's going to be the big idea with this section. For example, number 1, it says simplify the square root of 500. Alright, the biggest thing we're going to remember is no decimals. If you give me a decimal answer, I'm going to give you 0 points. So if you did this, you put in your calculator the square root of 500, and it gives you 22.36. That's going to give you 0 points. And I want you to show your work, because there are some ways to find radicals, simplified radicals, without doing any work. So you need to show me your work to get any credit. All right, so you must show work. If you don't do that, 0 points. All right. So what I'm going to do is I'm going to look for 500 on my list. Or basically, I'm going to put in my calculator and make sure it wasn't perfect. All right, it's not. So I'm going to look for a number that I underline in red that goes into 500. I don't care about 2 or 250, because neither one of those are perfect. 2, not perfect. 250, not perfect. See, that's why I don't care about that one. So instead of me guessing all the factors and worrying about all the factors, I just use my list. So basically, I start at the bottom and I work my way up. So remember, we talked a long time ago how, like, you know, Drake stole my thunder when he talked about starting from the bottom, and he wasn't really talking about starting from the bottom, because that kid's been rich his whole life. We were talking about starting from the bottom of our list, starting from the bottom when we solve backwards, starting from the bottom of our list. So I'm going to start for 400. I'm going to look for one of these numbers that goes into the biggest number that goes into 500. So like 400, and I just put my calculator, 500 divided by 400, decimal, 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 keep on going, decimal, decimal. 100 is the biggest number. There will be a part 2 of this video. It's like messing up again, so I'm going to make a part 2 of this video starting from this point right here. So let's say